Hello everyone, I am Anushka. Today I am solving the first internal test paper of Introduction to Data Science. In this video, we are going to solve the part B, which is similarities and dissimilarities in feedback. So let's start. Here, the question number 5, briefly outline how to compute dissimilarities between students' feedback profiles described by. So the answer is dissimilarity computation methods. First is nominal attributes. Example, department, elective, chosen. These are categorical and we typically use one hot encoding to convert them to vectors. Example, 1, 0, 0 like this. And then compute dissimilarity 1 if difference and 0 if same, or use Hamming distance. B, asymmetric binary attribute. Example, attended workshop, yes, no. In this, we focus on the presence of attribute. If yes, yes matches are important, no, no matches are ignored. C, numeric attribute like CGPA, attendance percentage. In this, we use McVowen's distance metric, especially Euclidean k equals to 2 and Manthan k equals to 1 distance. In D, term frequency vector, example, keyword. In open text feedback, for text data, we use cosine similarities and embeddings. Cosine similarities measure the angle between vectors, which is better for high dimensional pairs data text than Euclidean distance. Now move to the next question, question number 6. Suppose two student faculty intersection profile A and B are represented by vectors which is 22, 10, 8, 10 and 20, 26, 3, 30 respectively, where attributes represent hours expend in mentoring, project review attendance, assessment submission and infrastructure uses count. Compute first Euclidean distance, B Manthan distance, C McVowen's distance with H3 and D supremum distance. So the tuple A is 22, 1, 42, 10 and the second one is 20, 0, 36, 8. So the difference is AI minus BI. According to this, we subtract the tuple A first element to the subtract the tuple B element, which is 22 minus 20 is equals to 2, 1 minus 0 is 1, 42 minus 36 is 6 and 10 minus 8 is 2. So first one is Euclidean distance, which is k equals to 2 and the formula is on the screen. You can see the formula. We put the values in this formula. So we get the answer is 6.71. Now in Manthan's distance, here k equals to 1 and the formula is on the screen and we put the values in this formula to calculate the Manthan's distance. See in McNovan distance, which s equals to 3 and the formula is given on the screen and you can see the formula and we put the values in the formula and we get the Minkovan's distance with h3 is 6.15. For D, supremum distance, this correspond to the limit as k is equals to infinite in McVowen's. It is the maximum single dimension difference, which is 2162 is the maximum of in this is 6. So the supremum distance is 6. Now move to the next question, question number 7. Median score is often a key holistic indicator of faculty and infrastructure performance when the dealing with the massive student feedback data. Sets proposed method for the median approximation, analyze their complexity, and suggest heuristic to balance the accuracy versus efficiency. So the answer is median score is a massive student data set method for median approximation when the data cannot fit in the memory of a single machine. We face big data challenges. First, binning or histogram approach. Partition of the range of the value into bins, count the frequency in each bins using the map reduce. The map face count item per bins reduce aggregates. We can identify which bin contain the median and interpolation. Similar to Q3. Second one is sampling. Use Monte Carlo sampling or reservoir sampling to select the representative subset of the data and calculate the median of the sample. Third one is heuristic. Complexity, shorting the full data set in omega n log n, which is expensive distributed binning in omega n one pass. Approximately we trade accuracy for speed. Now move to the next question, question number 8. Consider student facility similarity analysis, a sample data set of two attribute faculty responsiveness and infrastructure support. So A1 is faculty responsiveness and A2 is infrastructure support. You can see the table on the screen. Give a new feedback query x equals to 4.4 and 1.6. The sub question is A is rank existing student feedback profile by similarities using Euclidean, Manthan, supremum and cosine similarity. So the data is in, we can write the data in data sets like this. You can see on the screen. Now, rank by similarities distance, we calculate the distance between x and each student, smaller distance and higher similarities. Euclidean formula is written on the screen. We put the value, number wise number in the formula and get the answers. So we get the answer of S4 0.22, S3 is 0.28, S1 is 0.41, S5 is 0.61 and S3 is 0.67. Now normalize the unit length. To normalize, divide the vector by its magnitude. This convert data to the standard range and direction, which is often necessary before computing distance. This relates to cosine similarities, which calculate similarities between normalized vector dot product. Example, normalization of query 4.1.4 and 1.6, the magnitude will be under root 1.4 square plus 1.6 square, which calculated, and the answer will be 2.126, and the normalization of x will be 0.658 and 0.752. So move to the next question. Okay, we complete all the questions. Thank you.